Welcome to the video lecture series on C programming training session. In today's video lecture, we'll be learning about control systems and its operators. And we'll be learning about control systems and operators in an elaborate fashion. This is Dr.K.N.Sivabalan. And the first thing which we are going to learn about control systems is we are going to learn about operator precedence. So without knowing the operator precedence, we cannot evaluate an expression in a C program. For instance, in this case, we have arithmetic, logical, relational, and bitwise operators. So, for an example, I have taken A is greater than B, and A and B are called as operands, and greater than is called as an operator. So, we should be able to categorize what is operands and what is operators in this scenario. Now, as far as operators is concerned, we'll be learning about this in an elaborate fashion. Okay. Now, the next concept here is what are the types of operators. So the types of operators, we have arithmetic operators spanning from addition, subtraction, multiplication, division and modulo. You have unary operators also, unary plus and minus, and post increment and decrement operators. Now we have to be able to identify when the input is given, what will be the output in this case. In this case, I have taken a code snippet called as A is taking a value called as 10. Now I actually make A plus plus. So this is called as a post increment operator. So post increment operator actually stores the value, then increments the value. So post increment stores and then increment. So it stores the value and increment. Stores the value means first 10 will be given to B and then 10 will get incremented to 11. Now when I try to print B here, B will have only 10. So that's why we are getting 10 and A will have 11 because first it stores the value and then it prints. Now in the next case, we have a pre-increment operator. Pre-increment operator is increment and then stores. So that is the difference. So in this case, A will get incremented first, okay, and then it will store. Now in this case, it increments, it will become 11. 11 will be assigned to B, and now when I print B and A, it will be 11 and 11. So that's how it works. Now when we go for relational operators, we have greater than or equal to, less than or equal to, not equal to, so on and so forth. So now when I have an expression called as A equal to 10, if A is greater than 5, what does it mean? Now it will result, A value is 10 now, so A value is 10. So 10 greater than 5. So obviously the condition is true. When the condition is true, it will be resulting in 1. If the condition is false, it will be resulting in 0. So when I print B, I will get 1 here. Now in this case, here A is equal to 10. Now what is the assignment here? A is equal to 5. That means 10 is equal to 5. Obviously the condition is false. So in this case, condition is false. When the condition is false, it will take a value called as 0. So B will take a value called as 0. So I get, when I print B, I am getting 0 here. So this kind of code snippets, we have to be very thorough because it is highly important and significant for placement perspective. So next is what is meant by logical operators. We have logical AND, logical OR, and logical NOT. Now A and 12. Okay, so any value other than 1 or 0 will be considered as true. So A is 10, so 10 and 12. So both these conditions will be resulting in true. So this is a positive value, this is a positive value. So it is not 0 value, so it will be true. So B will take a value called as 1. So B will take a value in this case called as 1. Now A and 12. So A is actually 10 or 12. So if any one value is true, or will take a value called as true. So this will be having another value called as 1 again. Now not of A. Not of A means if A is positive value, then obviously it will go for a false value. So not of A means 10 will be negated and 10 will be made as 0. So now D will get a value called as 0. So when I print A, B, C, A will get 10, B will get 1, C will get 1 and D will get 0. So negated value will get for D. Now What is bitwise operator? So we have bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, a complement, right shift and left shift. Now what is bitwise AND? Now see here, I make a bitwise AND for 10 and 5. So 10 will be equivalent binary value will be 1010 and 5 value will be 0101. So when I try to bitwise AND it will be resulting in 0 now. So you will get 0. Now when I make the complement of 6, complement of 6 means all zeros will become 1 and 1 will become 0. So what is the value for 6 here? So 6 will take a value here. 6 will take a value here. So 6 will take a value. In this case, we have 6 here. 6 will take a value 0, 1, 1, 0. Now when we complement it, all zeros will become 1 and 1s will become 0. So that is equivalent to 9 here. So now you will get a value called as 0 and minus 7. So minus 7 in this case will be equivalent to this one, minus 7. So A equal to 20. Now what is A equal to 20? When A equal to 20, I just right shift 2. When I right shift 2, that means divided by 2 times. So 20 divided by 2 first time, it will get 10. 10 divided by 2 second time will be 5. So obviously B will have a value called as 5 in this case. So you have 5 here. Now when we talk about assignment operators, simple assignment operator and compound assignment operators, when you have plus and equal to, these are all called as compound assignment operators. You have other operators here. That is equivalent to, now A is equal to 40, A plus equal to 40. This is equivalent to A equal to A plus 10. So that is the meaning of this. So obviously now in this case A will become 50. Now you will get an answer called as 50 in this case. Now the comma operator, very crucial operator as far as C programming is concerned. So it has the lowest precedence comparatively to other operators. Now when we talk about command operator here, comma operator here, first operand, and the use of comma operator here is, in this case we have brackets here. Brackets has the highest precedence and comma has the least precedence here. So we have 3 values here, 10, 20 and 30. So use of comma operator will take the value and ignore that. So first it will take 10, it will ignore that. Then it will take 20, it will ignore that. Finally it will take 30. Now value of A will be 30 here. So that is the meaning of it. Now in this case, when I have A equal to 10, 20, 30, now this is equivalent to like this. So it takes a value like this. Okay. So now since there is not any precedence over here, automatically it will result in an error message. Now when you come integer A 10, 20, 30, now it will, since we are not using brackets here, automatically the first value 10 will be assigned to A. So the difference between here and here is, if you are not using brackets along with initialization and declaration, then obviously it will result in an error. So this will be resulting in an error. But here declaration is in the first line and you are making assignment on the second line. So this is accepted. So 10 will be assigned to A. So you will get a value called as 10 in this case. Now comma can also be used as a terminator or as a separator value. So in this case I am using it as a separator, so it will be used to separate multiple statements together. Now print of 1 comma, instead of putting a semicolon, semicolon is called as a termination symbol. But if we want to terminate finally, you have to put semicolon. Now in this case 1 comma 2, print of 2 comma then 3 will be is actually ending with a semicolon. Now the result will be 1, 2 and 3 in this case. So it won't show you any error here. Now the advantage of conditional operator is called as ternary operator. This is also called as ternary operator. So now in this case, when A is taking a 5 and N is taking a value, M is taking 5 and N is taking 4, in both cases if M is greater than N, obviously the condition which is after the question mark will take an impact here. So M5, N4. Okay, so M is obviously 5 is greater than 4. So the condition is true. So true means this portion will be getting executed. So this portion will get executed. So now you will get m is greater than n, that is 5 is greater than 4, 5. So this will be printed. So if condition is false, then the statement which is after this semicolon will take an impact. Now in this case condition is true, so we are actually ignoring that. Now you can use conditional operator multiple times also. Now see here, 2 is greater than 3. So condition is false. When condition is false, this will be going to after semicolon. So after colon. So now again there is a condition 6 greater than 7. That is also false. Okay. So it will take a condition after this colon. So after this colon you have 12. So 12 will be assigned to A. So you get 12. So that is the reason why you are getting 12 in this case. Now we have to be very thorough with operator precedence. Operator precedence has a sequence of priority. So this operators has to be executed in an order of priority. Otherwise, if priority is not given, then there will be literal confusion in evaluating a C expression. So we have parenthesis at the highest priority, array subscript, dot operator, structure operator, post increment, pre increment, then followed by star, dereference operator, size of operators, all this has the highest priority, typecasting, then relational operators comes next, and bitwise operator comes next, then arithmetic operators, then bitwise right shift and left shift, then bitwise exclusive or, then logical operators, logical and, logical or, logical not comes next. And these are called as assignment operators. Assignment operators has the least priority, comma has the most least priority. Now coming to this one, so which has the highest value? Now this case, we can see here arithmetic operators has the highest precedence. You have bitwise operators also, right shift and left shift. So 3 is to 4, 3 into 4 is 12. So 12 greater than 2, right shift 2 and left shift 1. So now we have one right shift operator and one left shift operator. So what is the associativity? Both have equal precedence. Evaluate from left to right. Evaluate from left to right. So when you evaluate left to right, so this will get evaluated first, this portion. Okay, 12 divided by 2 times. 12 divided by 2 is 6 and 6 divided by 2 is 3. Now this 3 we have to apply this one. Okay, now left shift operator. Left shift operator means multiplied by 2 one time. So 3 into 2, it is equal to 6. So answer is actually 6 in this case. Now when I apply here 9, now we can see here that plus 9 is equal to 10. 10 is greater than 5 plus 4 is 9. Okay, now pre-increment operator has the highest precedence, so 10 greater than 9, the condition is true, so it will be resulting in 1. So B will take a value called as 1. Now in this case, okay, 10 greater than 5, so condition is true. Okay, condition is true, so it will be resulting in 1. 1 plus 4 is equal to 5, so B will take a value called as 5. So we should be very thorough with evaluating these expressions. Now the condition here. So if statement evaluates to true or false, if it also works in a numerical values. Numerical value means I can simply assign a numerical value instead of a condition. So in this case, A equal to 4. Now A equal to 4 means it is not comparison operator, because comparison operator we have to use 2 equal to's. Okay, but here I am using only 1 equal to, that is called as a assignment operator. That means A takes a value called as 4. So A takes a value called as 4. What does it mean? Any value other than 0 will be considered as true. Okay, 0 is false. Any value, all values are true. Except 0, all values are true. So I take 4 as a value here. So 4 is true. Now I will get an answer called as welcome. Now it is not comparing with 5. Okay, it is not comparing with 5. It simply takes A is equal to 4. That's all. And for loop. Now the conventional way of for loop is we have 3 separations or 3 segregations in for loop. I is equal to 1. I will be spanning from 1 to 5 and it will be printed from 1, 2, 3, 4, 5. So this is the conventional way of representing a loop. But when a for loop is actually terminated with semicolon, now you can see that I is equal to 6. So now this printf does not have any connection with this for loop here. Now what does it mean? So when I make a for loop, I is equal to 1, I less than or equal to 5, I plus plus. If I put semicolon at the end, it is equivalent to putting a semicolon in the next line. Now for loop has connected only to the empty statement on the next line. Okay, that means if I put semicolon like this, it is equivalent to this. It is equivalent to this. Now after this statement have no connection with for loop. Now I will get terminated when I become 6. Okay, now when I become 6, loops get terminated. Now it will come out of the loop. Now I will print value called as 6. Now initialization of for loop and increment can be done outside of the for loop. So initialization is done outside of the for loop, condition is inside the for loop. Now increment is also inside the body of the for loop. So this will be executing 1, 2, 3, 4, 5. So for loop have can break the conventions, and for loop can be represented in this order also. Now in this case, for loop have how many segregations here? So you can see that for loop have 6 portions here, spanning from I is equal to 1, j is equal to 3, I less than or equal to 3, 5, and j less than or equal to 5. Now understand that whenever you have a comma, the rightmost part has the highest priority. Okay, highest priority will be given to the rightmost part. Now in these two conditions, j is equal to less than or equal to 5 has the highest priority. So I is equal to 1, j equal to 3. First time I will be 1, j will be 3. Next time I will be incremented to 2, j will be incremented to 2 again. Okay, j will be incremented to 4. Now 2 less than 5, it is okay. 3 less than or 5, both conditions are true. Now 2 and 4. 2 and 4 will get printed. Now next time I will be incremented to 3 and j will be incremented to 5. Now do these two conditions work now? Now again 3 and 5 will get printed. Now I will be incremented to 4, j will be incremented to 6. Now when we compare here, I condition is true. I is 4 less than or equal to 5. But j 6 less than or equal to 5 is false. So okay. So since condition which have highest priority is on the right side, so this breaks off. So entire loops come out. So the answer is 1, 3, 2, 4 and 3, 5. Okay, and when you use for loop in this format, for loop with double quotes with two semicolons, it is called as a infinite loop. Okay, so now when I make like this, for semicolon semicolon 2 times, and inside this I make printf. If I make printf like this, if I print of 1, though this will be printing infinite number of times. Infinite loop. So this is an infinite loop and it will be printed infinite number of times. So that's how it works. Now the continuous statement. So when you talk about continuous statement, it actually skips one iteration. For example, when I is greater than or equal to 2, greater than 2, it will skip the iteration. So what will be the output? Initially I is equal to 1. Now condition is false, so I will get printed. Next I will be 2, so 1, 2 will get printed. After that I will become 3. When I becomes 3, so this continuous statement keeps on executing for all iterations. So spanning from 3 to 5, continuous statement executes. So it will never come to this printf after this. So answer is 1 and 2. Answer is 1 and 2. Now the break statement will permanently quit the loops. Now in this case here, when I is equal to 2, it will break the loop. Okay, so now 1, 1, first time I and j will get printed. Next is 1, 2, next is 1, 3. Then listen carefully. So this break will always break the inner loop. It will break only the inner loop. Okay, so when I becomes 2, it will break the inner loop. So you can see here that when I becomes 2, you are not getting any output related to I. So it comes like this. So the go to statement. So go to is unconventional procedure. It is not a good coding practice to use go to in our C programming. But anyhow, still the go to syntax exists. Now go to will be jumping the control, transferring the control to a label. So when I becomes 2, now it has to transfer the control to a label called as lab here. So it should be capital L. Okay, it should be capital L. Now I is equal to 1, so condition fails now. Now I will get printed 1. Now when I becomes 2, it will be transferring the control to lab. So control will be transferred from this position to this position. It will come out of the loop. So the output will be lab 1 and exit. Okay, so loop will not get executed further. And switch case. So only integers and characters are accepted in the switch cases. Now in this case, a is equal to 1, a is equal to 1 is an integer now. So 1, case 1. So 1 will get printed. So it matches with case 1. So 1 will get printed. It will break and come out. Now as far as switch case is concerned, this break statements are optional. It is only optional. It can be used or it can be ignored. Okay, this case is only optional. Now coming to the next one, switch case can also be used for ranges. Now this is unconventional procedure. Even ranges are supported in switch case in the subsequent compiler versions. Now a is equal to 7. A falls under the range of 1 to 10, so it will print value below 10 here. Okay, so the next is a is equal to 1 in this case. Now switch a case, it matches with case 1. Case 1 means print 1. Since there is no break statement, it will actually control will be transferred to the subsequent case also. When it goes to subsequent case, 1 and 2 will get printed. So you will get 1 and 2. So these two statements will get printed and it will come out in this case. Now a logical AND. Now what is meant by logical AND? So logical AND, you can see here that the advantage of logical AND is, now if any one condition is, if both the conditions are true, then only it will become true. So now a is greater than 10, a is 20, so obviously this is true, and a is equal to 50. Now this is also true. Now a takes a value called as 15, so both conditions are true. Now when I print a, the answer will be 15. Why? Because since this condition is true, it will evaluate to the second condition. When a second condition is also true, that means a is taking a value called as 15. It will take a value called as 15 now. So it will print a is equal to 15. So that's it. Logical and evaluates the second condition if the first condition is true. So suppose if the first condition is false here, it will not come to the second condition at all. Immediately it will go and say that the answer of a now. Now in this case, if a is greater than 30 and a is equal to 50. Now see here, first condition is false. Now a is greater than 30. It's false actually. Since it is false, it won't go to the next condition at all. It will come here. It will take a is equal to 1. Now, and after when I print, if this is, see, condition is false here. Since condition is false, it will come to this printf. Now a will be taking a value called as 20 because initial value of a is actually 20 here. Now logical OR, if any one condition is true, it won't evaluate the second condition. Now in this case, a is equal to 20, so a is greater than 10, so this is true. So there is no need to evaluate this condition at all. So when I print a, it will take the value called as 20. It will print the value called as 20. Now you take a equal to 20. Now second condition, if a is greater than 30, now this condition is false. So if the first condition is false for an OR logical operation, then it will evaluate the second condition. So it will evaluate this condition. Now a is taking a value called as 15. So this will be true. Now a will be printing a value called as true. So that is a difference, ideal difference between a logical AND and logical OR operation. Okay. Now we will just go for the quiz statements here. Now the quiz statement here. So what does it mean? So this is equivalent to 5 plus Geeks quiz. This is equivalent to 5 plus Geeks quiz. Now see here. it will move 5 positions from the base value. So base value starts here 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So cursor control actually stands here. Okay, now what I want to print? I want to print percentage C. Percentage C means it will print only the character. So what is the character at this position? So Q is the character, so Q will get printed. So the output is Q in this case. Okay, now what is the difference between gets and scanf? Okay, gets will be taking even a blank space into account. Say for example, when I say CSE space B, okay, it will take this space into account and it will print CSE B. But when I use space in scanf, it will ignore the space, and it will only print CSE. Okay, so that is the difference between gets and scanf. So gets can read a string with spaces, but normal scanf with percentages cannot. Now find output here. Okay, find output means, so I have used a percentage star here. I put a string for this SRITCB. So when n is equal to 3, so n is equal to 3 means I have used here star. Star means this star is called as a replacement operator. N is actually substituted in this place. Now that means it is equivalent to dot 3s. Okay, dot 3s. What does it mean by dot 3s? Now from the right side, it will print 3 characters. From the right side, it will print 3 characters. So the answer will be CBE. Okay, okay. From the right, it will be printing. From the left, it will be printing 3 characters. From the left, it will be printing 3 characters. It is SRI. So the answer is SRI. So in this case, now see here, find the output for this printf Zeek's quiz. Now the advantage of printf is it not only prints this Zeek's quiz, it also returns the number of characters it prints. So how many characters it is printing? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it will return a value called as 9 now. Okay. So X will take a value called as 9. So when I print X, it will be this Zeek's quiz will be there as an output. Then X will be printed as 9. So you get 2 outputs now. So Zeek's quiz and 9 as an output. Now coming to this one. So printf percentage D. How many characters is printing? First it will print 1, 2, 3, 4. Okay, now it is printing 4 characters, 1, 2, 3 and 4 characters. Now this will be giving 4 as an output to this one. Now when I print now, you will get 1, 2, 3, 4 and 4 will be the output. And this one, you have a function called as foo, and to make a call for this function, generally function will be called like this. Okay, with this parenthesis it will be called, but here I am not using this parenthesis, but it will not result in any error here because it will simply represent the address of the function. So it will address of function, it will simply represent the address of the function. Okay, so no error will be there for this function, for this output or program. So no compiler error, but foo functions wouldn't get executed. Program won't print anything. Okay. Now, as far as scanf is concerned, we have 2 inputs here. We are reading 2 inputs A and B, but nature of scanf is actually it will read these 2 inputs and it will return how many inputs it is reading. So it will return 2. So it will return 2 here for this scanf. So it will return 2 to C. Now, if A is getting some value, we will see A is getting an input called as 30, 40, and since you are getting 2 inputs, it will return 2 to C. So it will get 30, 40 and 2 will be the answer for this. Now, the next question is, you have A is equal to 10. Now, 10 plus 1 will be 11 for this first output. Now, next is A is equal to 10 now. 10 plus 2 will be 12. So B will be taking the value called as 12, but it won't get printed here. Okay, now in the next line, B will get printed. So here the output will be 12. So the answer is 11 and 12 in this case. So you can see here, now we are getting 11 and 12 as an output. Now coming to this one, X is taking a value called as 128. 1 plus x plus plus. It's a post increment operator. Post increment operator first gives the value and then increment. So it will give a value called as 128. Okay, plus 1. So answer will be 129. So the output will be 129. Now coming to the next one. Now in this case, see here, I am scanning an array. I get an input for an array. Suppose if this is given as an input, scan quiz. Okay. Now scanf will return how many input it is getting. How many inputs it is getting? It is actually getting only one input in this case. So it will return 1 to this printf. It will return 1 to this printf. So the output will be 1 in this case. So 1 is an output. Now the beauty of this is now we have welcome. We are using this escape sequences. Okay. Now when I use /b, cursor will be standing here. When I use /r, cursor will go to the front. Okay. So starting line it will go. Then I am printing gold. So what will happen is, since welcome, now cursor will be standing here after this R. Now from W onwards it will get overwritten. That means GOLD. Okay, so the first 4 characters will be replaced by gold. Okay, and now the output would be goldum. Okay, so now we can see here. So goldum is an output now. Now we have used this escape sequences. So this double quotes mentions a string, and these quotes will be mentioning this quotes inside the string. Okay, when I use 2 percentages, I will get only 1 percentage. So in these 2 cases, I will get only 1 percentage. So the output will be Geeks percentage for percentage Geeks and double quotes. So this will be the output. So we are getting this output now. Now 5 plus Geeks quiz. What does it mean? That means from the base value, go 5 characters on the right side. That means this is 0th character, this is 1, this is 2, this is 3, this is 4, and this is 5. So 5 actually starts from Q. Okay, so from Q to remaining characters it will get printed. So the output is QUUZ. This will get printed. Okay. Now scanf. So in this scanf I am using a value called as 4s. That means it will get only 4 characters. Suppose if I give an input called as welcome. So first 4 characters will be received as an input, WELO. So when I print str, so the answer will be WELC will be the output. First 4 characters will get printed. Now you can see here, in this case 3 values has been assigned. Size of k bar. Okay, whenever we use size of, okay, this value will never get executed. Inside, if size of, if you give any expression or anything, it will never get executed. Never get executed. Inside size of never will get executed. Nothing will get executed. But instead of that, all these operands, whatever you are using, is called as integer. So integer bytes is actually 4. So size of integer is 4. So you will get an answer called as 4 in this code. Now you are getting 4. And when I print k value is actually having 15. So you get 4 and 15 is the answer for this. Okay, again, listen carefully. So printf will print the number of characters. So printf, there are 9 characters here. Now 9 is an integer value. So 9 will be returned to size of. So size of 9 is an integer. Size of 9 is an integer. Integer means 4 characters will be printed. So size of integer is 4. So you will get an output called as 4. Now this is the operator here. So a equal to 1, b equal to 1. Now see here, a is 1 now, or b is 0. Okay, now what is the condition? If any one condition is true, it is true. So since a is 1, so c will take the value called as 1 as the first output. Now here, a will be 1 now, B will be already 0. 0 minus 0 is 1. Now D will be false here. So you will get A1, B1, C0 and D0. So this value will be equivalent to 0 as an output. Now we have multiple conditions. So when more than one condition is here, it will be evaluated from left to right. Okay, first C greater than B. So C is C greater than B greater than A. Okay, C is 30, 30 greater than B is 20. Okay, and greater than A is 10. Now 30 greater than 20 is true. So it will be evaluated to 1. Now 1 greater than 10. So the condition is false. 1 is not never greater than 10. So it will be false now. So when it is false, you will get an answer called as false. So now this is very crucial. Now we have left shift operator, right shift operator and an additional operator. So which will get evaluated first? So this 2 plus 3 will get evaluated first. So what will happen is 1 less than or equal to 2 plus 3, 4. Okay. Now this 2 plus 3 will get evaluated first. So 1 less than 5 less than 4. Okay. So right shift. This is left shift operator. Now first this will get evaluated. Okay, from left to right. Okay, 1, 2 into 1 is 2. First time 2 into 1, 2 into 1 is 2. Then 2 into 2 is 4. Then 4 into 2 is 8. Then 8 into 2 is 16. And 16 into 2 is 32. 16 into 2 is 32. Okay. Now, again this 32 will be evaluated 4 times. 32 will be evaluated 4 times here. So 32 will be evaluated, 32 into 4 is, Professor, morning, Professor. 32 will be 64, 64 will be evaluated to 2, 124, 124 into 2 is 248. 248 into 2 is 512. So the answer will be 512 here. Now we have these operations here. Now initially x is equal to 10 and y is equal to 20. So x we have 10 and y plus 10. Okay. So y will be become 20 plus 10 is 30. Okay, and x is already 10 here. 30 plus will be 10 will be 40. So the answer is for x will be 40 and y will be 30. So here 40 and 30 will be the output. Finally, we have x is equal to 10, x plus plus, x plus plus, x plus plus. Now, we have this 10. So, 10 will be incremented to 11 in this case. Now, 11 will be incremented to 12 here. But this is a post increment operator. Okay, first it will give the value. Now, this will be incremented to 13. But understand that it will first assign the value called as 12 to y. So 12, y will be taking the value called as 12 and then x will be now at this moment it will be 13. So when I print x, it will be 13 and when I print y, it will be 12. This case. Final answer. Now a is equal to 1. So a is equal to 1. Now first left side to right side. Right side to left side, 0 is equal to 1. So this condition is false. When this condition is false, it will be resulting in 0. So I will just write it here. A double equal to 1. So a is equal to 0. 0 equal to 1 is false. So it will be resulting in 0. Now a is equal to 0. Okay, next a is equal to 0. Come outside. A is already 0. So 0 equal to 0 will be true now. So it will be, the answer will be 1. So the answer here in this case is 1. Now this is a very crucial operation, 570. It is an octal representation. So octal representation, first we have to convert that into an integer. So 5700. So 0 into 8 to the power of 1. 8 to the power of 0 is 0. 7 into 8 to the power of 1 is 56. 5 into 8 to the power of 2 is equal to 8 squared is 64. Okay. 5 into 60 is 300, 3 into 320, so 320 is 376. So the answer is 376. Okay, so when we have 376, okay, now shift right 2 times. So 376 shifted 2 times. 2 times means you have to divide it by 2 times. So 376 divided by 2 will be 188. 188 again divided by 2 will be equivalent to 94. Okay. Now in this case we have equivalent value called as 94. Now 94, left shift 1. Left shift 1 means multiply by 2. 94 into 2 will be 188. Now understand that we have to make an octal representation for this number. So 188 octal representation. So how to make 188 into octal? So 188 divided by 8. How many times it goes? It goes 2 and this goes to 28. 28 is actually 3 and remaining is 4. Okay. Now 23 divided by 8, it goes 2 times and here we have 7. So the answer is 274. So the output here in this case is 274. So now you can see here it is 274 will be the output. Now the first is before this arithmetic operation, relational operation, arithmetic operation will get executed. So so in this case relational operator y less than I. Okay, so y value is here it is 0, I value is 0, 0 less than 0 is actually false, so it will be 0. So x multiplied by 0 will be totally 0 and here plus j. So plus j, what is plus j now? Plus j is actually 1 bar k. Okay, and k is actually minus 1. Okay, so 1 bar minus 1. Okay, both values are actually resulting in true, so the answer is 1 will be the output. Okay, so answer is 1. So that's about the practices of C programming. So thanks for watching the video. Have a good day.